In this section, we continue with our curve sketching techniques because in the prior section, we didn't discuss anything dealing with asymptotes because polynomial functions do not have asymptotes, but our rational, logarithmic, and exponential functions do. So our final version of graphing strategy is that in this first part, we need to make sure that we find our asymptotes. Then we continue the same way, analyzing our first derivative, analyzing our second derivative, and then in our sketching, we need to make sure that we include drawing our asymptotes. And of course, then plot any additional points as needed to complete our sketch. So the first one we're going to do, rational function, is 2x over 1 minus x. So the first step, domain, x cannot equal 1, y-intercept, putting a 0 in for x, we get y equals 2. X-intercept, set the numerator equal to 0. We get x equals 0. Asymptotes. Vertical asymptote is at x equals 1. Horizontal asymptote, we take notice, we're going to use those previous rules we did before, where we look at the degree of the numerator and the degree of the denominator. And the degree of the numerator and the degree of the denominator are the same, so we use the coefficients, which would be y equals -2, or 2 over -1. Okay, second part. Take the derivative. So we have our quotient, derivative of the quotient, so our first derivative is the bottom times the top, derivative of top, which would be 2 minus the top times derivative of the bottom, which is -2x, all over the bottom squared. So you get 2 minus 2x plus 2x over 1 minus x squared, which is 2 over 1 minus x squared. So critical value of 1. The denominator will always be positive. So this is increasing negative infinity to infinity. Second derivative. Second derivative is derivative of the first. So we have our bottom and our top. So the second derivative equals 0 minus, which is going to turn to a plus because of this minus right here. We get 4, 1 minus x all over the denominator squared. Squaring a squared gives me to the fourth. And we get, so once again, our value is 1. And in this case, because the denominator is an odd power, we will get when it is greater than 1, it's negative, and when it's less than 1, it's positive. So this is a point of inflection. And it is up from negative infinity to 1 and concave down. So now we can go ahead and graph this. I'm going to shrink some things here. And go ahead and graph. So we need to just make sure that we include our asymptotes, which are at x equals 1 and y equals negative 2. Then we plot our intercept. X-intercept is 0. And y-intercept oh, sorry about that. Hope you guys caught that. That this should be 0, right? When I substitute a 0 in there. My apologies. I'm sure you were totally confused. Now, I know that it is up and increasing, and it's down and decreasing on the other side of 1. So let's just plot a point on the other side of 1. So I'm going to just pick 2. So I put 2 in my original function. 2 times 2 is 4. 1 minus 2 is negative 1. So I get negative 4. So it'll be here. And it will look like so. And I don't want to say that this, I should have also said that this isn't really a point of inflection either, because it's not in our domain. So I misinformed you on that too. Because our value of 1 is not in our original domain, it's not defined at 1, that can't be a point of inflection. Okay, so go ahead and try matched problem. Number 2, because this is the one I just did. So the matched problem, I know it's kind of a mess, but hopefully you can just check what you got and able to ask those questions if you need to when we meet. So I'm going to let this just play for a while so that you can check everything, and I didn't show all my work for everything.